In this video, let us see about the substitution reactions of alcohols. See, in alcohols, the general formula for alcohols is ROH. In alcohols, the substitution reaction will takes place not very readily like that of alkyl halides. In case of alkyl halides, substitution reactions take place in a very fast manner in the presence of a strong base, because that bond between the alkyl halide, that is the R, and the halogen group is a weak one, because that halides are weaker bases. But in the case of ROH, that is alcohols, aliphatic hydroxy compounds, the bond between the alkyl group and the oxygen atom, because of that OH group being a weak, stronger base, that bond is a very strong bond and it is not very easy to break that bond. Okay, so what we have to do is, we have to weaken that bond. How to weaken that bond? In the making us being a stronger base, OH minus ion being a stronger base which is attached to the alkyl group cannot be broken very easily. So we have to weaken it. We have to convert that into a weaker base. So what is the method? Method is, in order to we can protonate it and convert it into water molecule which is a weak base. In that way we can break that ROH bond, and so substitution reactions can be carried out. See, let us see the types of reactions, how are they taking place, what mechanism it is following, whether it is SN1 or SN2, we can see this in this video. See, they are the leaving halide groups being X minus, that is very weak, they are all weaker bases, so they are readily removed. Okay, but alcohols less reactive than alkyl halides in substitution and elimination reactions, because they are strongly basic, and so we need catalyst to break that bond. Okay, now we'll see the substitution reactions in case of alcohols. Here what happens is, this bromide ion, if instead of OH minus ion is replaced by bromide ion, but this will not take place readily and no such reaction is possible simply with the bromide ion alone, simply with sodium bromide. Like that we cannot do the reaction. But what happens? See, OH group must be converted into a weaker base which acts as a better leaving group. Now see what way is to convert the big OH group to a weaker base? It is to protonate it. See the reaction? You can see the CH3OH, that is an methanol plus HBr. So hydrobromic acid is used. In this place you can also use hydroiodic acid also. Both will react in the same way. HI. So what happens? This O oxygen carrying lone pair of electrons will accept that H plus. Here it acts as a base and it readily accepts that H plus, and so what happens is the H plus goes and attaches to this oxygen, so making that oxygen positively charged. You know that oxygen, which is highly electronegative, carries a positive charge. So what happens? It becomes more electronegative and the bond between carbon and oxygen becomes weaker and it immediately breaks. And so what you are getting is methyl bromide plus water, which is a weak base. So here this substitution reaction requires heat energy. So what happens? And it takes place in a reasonable period of time. So it takes somewhat a longer time. Activation energy needed is more. Okay. Now coming to the primary, secondary and tertiary alcohols, they all undergo nucleophilic substitution reactions with the hydrogen iodide, hydrogen bromide and HCl to form alcohol. See the reactions, you can understand the reactions. I have given 3 examples, one with the primary alcohol, that with again the same type of reaction on heating with hydrogen iodide you get iodo-propane, and then for secondary alcohol I have taken an example as cyclohexanol. Okay, and so you are getting is bromocyclohexane, and the third example is a tertiary alcohol, and that with HCl a product is formed. Okay, so all the 3 alcohols react with this hydroiodic acids or halo acids and then give the product alkyl halides. Okay. Now coming to the mechanism, see secondary and tertiary alcohols, you know they undergo SN1 reaction, that is nucleophilic substitution, unimolecular nucleophilic substitution reactions. See the mechanism. So how will the reaction take place? It takes place via 2 steps, that is via the formation of a carbocation intermediate. Okay, now see the reaction. See first what happens? Protonation of the most basic atom, which is the oxygen atom. Okay, and so what happens? The oxygen accepts this H plus and it is converted to a positive oxygen. Okay, so formation of a carbocation by the removal of water molecule, making the bond a weak bond. So what happens, this a weak base goes out and we are getting a carbocation, and here the carbocation, now it reacts with the nucleophile to form the substitution product. In this reaction you can also expect this elimination product also, because as the carbocation is formed, if you are adding a bromide ion, what will happen, elimination can also take place, forming an alkene in the case of secondary or tertiary alcohols. But the dominating product will be a substitution product only, because if more amount of HBr is added, the compound will shift towards this alkyl halide part. Okay, so what happens, if water is present, it can form an elimination product, but if more amount of Br is present, it forms only a substitution product, and that will be the dominating one. Okay, and now coming to the next one. Yes? Ah. Ah. See, in the case of tertiary and secondary alcohols undergo substitution reactions with the hydrogen halides in a very faster manner than the secondary alcohols, because tertiary alcohols form tertiary carbocations which are very stable than that of the secondary carbocations, and so here the same type of reaction taking place in a tertiary alcohol and secondary alcohol, but the reaction, the first reaction, there is no need to heat. The reaction takes place at room temperature itself, but in the case of secondary alcohol with HBr, the reaction needs heat energy to take place, because here the secondary cation is formed. Okay, now we'll move to the next one, coming to primary alcohol. See, primary alcohol reacts with the hydrogen halides via an XN2 mechanism, that is bimolecular nucleophilic substitution reaction. So the reaction takes place in a concerted way, that is a single step. The reaction takes place in a single step. See the reaction, HBr, the time at which the HBr H attaches to the OH oxygen and the Br minus to the this one removal. So what happens is retention or inversion of configuration will take place, because the nucleophile attacks only at the back side. Removal of water molecule and the attack of the nucleophile by the back side, that is through rear attack, and takes place, and so the product will be always the inversion of configuration, and so this is the reaction with the primary alcohol. Here only the substitution product is obtained and no elimination product, because the halide ion is, although a good nucleophile, it is a weak base, and here in the case of elimination reaction, a strong base is needed to undergo the reaction. So only one product is obtained, that is a substituted product. Okay. Now we'll move to the next category. Instead of till now we have seen with HBr and HI, and in the case of HCl, when you are using hydrochloric acid, the reaction becomes slower, because Cl minus becomes a poorer nucleophile than the halide, than the bromide ion and the iodide ion. So what happens, the reaction takes place very slowly, and so in order to initiate the reaction, or you have to increase the rate of the reaction, we are adding a catalyst, that is zinc chloride. So what happens, first in the HCl, what happens, the zinc chloride first reacts with zinc chloride being a Lewis acid. It can act as a one which accepts 2 electrons from oxygen, and it attaches to this one oxygen atom. So what happens, zinc 2 plus attaches to oxygen atom and makes the oxygen positive or makes the bond weaker, and so the elimination is zinc hydroxide, and one zinc chlorohydroxide ion is removed, and the product is got. Okay, so in the case with the HCl, we need a catalyst for primary alcohol. Okay, see, so what happens is, in using this reagents, that is HCl and zinc chloride as a catalyst, this Lucas test is done to distinguish between primary, secondary and tertiary alcohol. See what we have to do, the given alcohol is mixed with the HCl and zinc chloride, so that is called as the Lucas reagent. And what we can see is, if the turbidity, you can see the difference, if the turbidity appears immediately, then it is a tertiary alcohol, because the reaction takes place in a very fast manner. And if the reaction, if there is no turbidity appearance only after few minutes or 10 minutes or 5 minutes, then the product will be, then the compound what we have taken is a secondary alcohol. And if the alcohol remains as such and the reaction will take place after a very long time, then that will be a primary alcohol, and the primary alcohol is soluble in this reagent, and so what we are getting is a colorless solution. Okay, so there is no turbidity in the case of a primary alcohol. So this test is useful for distinguishing between, making a difference between primary, secondary and tertiary alcohols. There is one more special case. In the case of when the reaction takes place in a secondary or tertiary alcohol via SN1 mechanism, the carbocation is formed as an intermediate. We have seen this already. So what we have to check is, the carbocation that is formed can rearrange itself according to Wolff rearrangement, or it is 1,2 hydride shift. What happens? The carbocation rearrangement can take place, and the rearrangement will tend towards the more stable carbocation. Say I have taken an example, 2-methyl-2-butanol, the HBr. So first the bond is weakened, and the removal, after removal you are getting a secondary carbocation. Instead of forming a product here in this position, this is the, see here, this is the minor product, and what happens? This carbocation, this methyl, this hydride shift takes place. This hydride ion present in the nearby carbon shifts to this carbon, and so what happens? You are getting a tertiary carbocation, and the tertiary carbocation, now it reacts with the bromide ion. This tertiary carbocation highly stable, it reacts with the bromide ion to form the major product. So what you have, see, the OH is present in the second carbon. Now the product what you are getting is that carbon, that OH group is moved to the next carbon, and so the product is bromide ion in the next carbon. This is because of carbocation rearrangement, and this is the predictor product. So this is a special case, in the case of special case according to, that is in the case of primary and secondary and tertiary alcohols undergoing substitution reactions. Okay, and now I have given some more few examples for you to work out, and so you can see the reactions, you find out the major product in these reactions, and you can give comments. You can clarify your doubts there if you want. Okay, thank you.